Okay, so here's the new tests. We have exactly 6 microseconds there. My time divisions are at 2 microseconds per division, and we're at 200 millivolts. And obviously we've got 3 divisions there, and that is our voltage across our CSR. And that is the input. 10.5 at 526 milliwatts. So let's do the math on that. 10.5 at 526 milliwatt. We have 5.5 watts going in, and that we are not delivering a load. Now I've removed the bulb, well actually I burnt the bulb, so I've just pulled some alligator clips here and added a 3 ohm resistor. So this does the same effect and is very close to what that bulb was, and it'll give us more accurate data. Okay, so now the next thing that we have to do is we have to put our resistor on, and I will do that now. Notice the magnetic field drops quite a bit, and our power obviously goes up. So we were at 5.5 watts without the load, and now I'll re-enter this data here. 10.4 volts at 566 at 566. So we're now at 5.8 watts, nearly 5.9 watts. Okay, so there is our CSR, and obviously it's gone up as well. Okay, so the next test is obviously if we put the diode in, it's open coil now, and that is the resistor with the diode and resistor, and obviously it changes nothing on the input because it's operating off of flyback. So now what I'll do is I'll take my scope probe off the CSR without frying anything here, and we're going to put that across our 3 ohm resistor here, and we're going to look at how much power we're delivering there. So now we'll be able to really calculate that. I have to drop my times divisions here. Okay, maybe a bit more. Okay, so there it is with the diode, and we're delivering basically 1.05 volts. And if we do our math on that, somewhere around 1.05 with 3 ohm resistor, so about 367 milliwatts. And obviously there is no cost. I'm taking the resistor off, resistor on, no cost, but not very much power. And now we'll put just the resistor alone, which cost us. So that is open coil, that is the resistor, and we already did that calculation, and that is what the scope shot looks like across the resistor. Just trying to adjust my get a lock here. Okay, so that's what the waveform looks like across the resistor. Obviously on time, here's flyback. We are delivering more power, about 1.3 volts RMS, and our time division and voltage are right there. So that's the only thing I change here is the voltage divisions. So now at 1.3 volts RMS, we're now having a little bit more power, but we're paying for it. So 563 milliwatts is being delivered to our load now. and obviously at a cost. And now we're going to do the 60 volt comparison, and if you keep in mind all these numbers, and you'll see the difference, and it is more efficient on the high voltage because we can deliver the same amount of power here with our diode. So it's a reverse scenario with the high voltage, and that's what I'm trying to show here, and you'll see that in the next video. Thanks, bye now.